Let's observe here the students a few more examples. Valence bond theory. Observe this complex and this complex. First of all, how many ligands are present? Here the 6 ligands are present, 4 ligands are present, here the 4 ligands are present. We know that ligands are 6 are present, obviously it is a octahedral complex. If the ligands are 4 present, that complex is tetrahedral or square planar. Tetrahedral and square planar, tetrahedral around the metal atom, all the 4 ligands are existing like this. Coordinate covalent bond is present. All the 4 ligands existing like this. Square planar complex means around the metal atom, the ligands are existing like a square. Ligand, 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 ligand. Here all the ligands and metal present in the same plane, that is a square planar complex. But here the tetrahedral ligands and metal doesn't present in the same plane. So what is the hybridization of these complexes and what is the magnetic behavior and what is the shape observed here? Each example now I am explaining. COF6 minus 3. You know that cobalt, what is the cobalt oxidation state here? Plus 3. Because of F minus 6, here the plus 3, here we are getting minus 3. 3d6, 4s 0. After losing the 3 electrons, cobalt basically valency is 3d7, 4s2. After losing 2 electrons, here the 1 electron, 3d6 is remaining. d6 having 6 electrons, d orbital 1, 2, 3, 4, 5, 6. This is 3d orbital. Beside 4s orbital is present. Beside 4p subshell is present. Beside 4d subshell is present. 4d subshell. But here the complex in the hybridization utilizing 4s orbital, 4p orbital, 4d orbital. This d orbital is the outer d orbital. This d orbital is the inner d orbital. The electrons are not pairing up. How it is given? How it is explained? Valence bond theory not explains. Valence bond theory just only observe the complex, the spectroscopy techniques, magnetic properties they observe. Here electrons are not pairing up, magnetic behavior is paramagnetic. This complex in the practical analysis, I mean spectroscopy data, gives that the paramagnetic behavior. Based on the paramagnetic behavior, hybridization is given. Remember this. So in the overlapping coordinate covalent bond, overlapping the fluorine, that fluoride ion utilizing these vacant orbitals. These vacant orbitals. So outer d orbital is using outer d orbital, inner d orbitals are not involving in the hybridization. So what is the hybridization here? sp3d2 hybridization. sp3d2 hybridization. What is the shape of the complex? Octahedral, we know that. What is the magnetic nature? Paramagnetic in nature. Magnetic nature is paramagnetic. How many unpaired electrons are present? N value 4. N value 4. Bohr magneton value calculation, root of n into n plus 2. This is the formula, Bohr magneton. So what is the magnetic value? Find out. 4 into 4 plus 2, here the 6, 24, root 24 value 4.90 magnetic property value. So this complex important point is, it is, students, this point is important. This complex in the bond formation with ligand, which d orbitals are utilizing? Outer d orbital or inner d orbital? If it is using inner d orbital, like CONH3 6 times plus 3, inner d orbital, hybridization is d2sp3. That complex is called as inner orbital complex, low spin complex. Another name is low spin complex. If he is using outer d orbital, that complex is high spin complex. So this complex is high spin complex, or outer orbital complex. High spin complex or outer orbital complex. So COF6 minus 3 complex is high spin complex, outer orbital complex, paramagnetic in nature, sp3d2 hybridization, octahedral complex. Next observe the next complex here. Next complex is nickel Cl4 minus 2. So according to valency bond theory, complex compounds are two types. Octahedral complexes, especially outer orbital complexes, inner orbital complexes. Outer orbital complexes means utilizing outer d orbital. Inner orbital complex means utilizing inner d orbital in the hybridization. D2sp3 inner orbital complex, sp3d2 outer orbital complex, sp3d2 high spin complex, d2sp3 low spin complex. One more point here. Basically, low spin complexes possible in strong field ligand cases and high spin complexes possible in weak field ligand cases, because of in the high spin electrons are not pairing up. If electrons are not pairing up, the complexes are simply called as, the ligand is simply called as weak field ligand. So here next complex, nickel valency, you know that 3d8 4s2. Nickel oxidation state here the +2. So 3d8 4s0. 3d8 4s0. In the D, how many orbitals are available? In the D, how many electrons are available? 1, 2, 3, 4, 5, 6, 7, 8 electrons are available. So here beside 4s is present, here the beside 4p is present. As per the magnetic properties identification, this complex is paramagnetic in nature. Paramagnetic means here the two unpaired electrons present and value is 2. So electrons are not pairing up based on the magnetic behavior observation. So remaining orbitals, here the 1s orbital, 3 p orbitals. So Cl minus ion ligand donate the pair of electrons to vacant orbital utilizing 4 orbitals. Here hybridization is sp3. Hybridization is sp3 means what is the shape of the complex? Tetrahedral. Tetrahedral. So hybridization is sp3, tetrahedral and paramagnetic in behavior. So Cl is considered as weak ligand. Ligand strength is not given by valency bond theory, it is given by exact explanation crystal field theory. That is, explanation is coming in the crystal field theory. Next complex observed here, NiCN 4 times minus 2. NiCN 4 times minus 2. Nickel oxidation state here +2. So 3d8 4s0. In the D, 8 electrons are available. So 1, 2, 3, 4, 5, 6, 7, 8. Based on the magnetic behavior observation, this electron is moving to here. Unpaired electrons are 0. Magnetic behavior point of view. So here the 4s beside 4p is present. So one vacant orbital is available in the D subshell. In the D subshell, one vacant orbital is available. Here one 4s orbital, one remaining 3p orbitals. The Cn minus donate the pair of electrons, one vacant d orbital and 2 p orbitals, one s orbital. So what is the hybridization observed here? dsp2 hybridization. Hybridization is dsp2 means what is the shape of the molecule? Square planar. Shape of the molecule is square planar. So as per the electron pairing, as per the magnetic behavior, electrons are pairing means this ligand is act as a strong ligand. The ligand is act as a strong ligand. So this is weak ligand, this is strong ligand, this is tetrahedral complex, this is square planar complex, sp3, dsp2 observation. So ligand, simply halogen here, halogen. Halide ligands are weak field ligands, simply halide ligands. And CO is CO means carbonyl, is a strong ligand. Cn minus is a strong ligand. And NH3 Specifically, it is act as a strong ligand in the case of cobalt +3 and in the case of chromium +3. So ligand's observation is very important. Ligand field strength, ligand strength decides the shape of the molecule and hybridization and magnetic behavior. These three things depends upon the field strength of the ligand. That explanation is coming in the crystal field theory. Okay, students. Few more examples on valency bond theory we are discussing on next video. Bye students.